right, so number 15 and 16 and 17, we are simplifying our radicals. So we look to see what we have, and the number underneath is not a perfect square. So I am going to write all the factors of 20. So 1 times 20, 2 times 10, 3 won't go, but 4 will go. It's 4 times 5, 5 will go, but I've already used it, so I'm done. So there are my list of all my factors of 20. If we don't know how to do that, we can always find it on the calculator. So let me get that pulled up, and I'm going to show you how to do that. Okay, so on the calculator, let me clear this off. Oh. Okay, so on my calculator, actually I need a graph. So I'm going to do 1, save nothing, 2. Okay, so at the graph, whatever the number is, and in this case it's 20 that I was trying to factor. So if I do 20 divided by x and hit enter, sometimes I'll see my graph, sometimes I won't, but what I'm really getting to is the table. So once I graph it, if I do Control T to see my table, then I can see my list of factors. I have 1 times 20, 2 times 10. I don't want any decimals, so I'm skipping that one. I have 4 times 5. If I keep going down, I have 5 times 4, which is the same thing. So once I start repeating, I know I have it. So those were the 3 sets of factors that I came up with just a minute ago. But if we struggle getting that, of course I can always use my calculator. Okay, so once I have my factors listed for me, I'm trying to find a perfect square. And of course, 1 is always a perfect square. 4 is a perfect square. And I believe that's all. So what I'm going to do over here is I'm going to rewrite this problem. Instead of saying the square root of 20, I'm going to write it with a set of factors. So I'm going to say 4 times 5. And then I can see that, okay, 4 is my perfect square. Well, the square root of 4 is 2. And then once I get here, then everything that's left stays under my radical. Okay? All right, let's do the next one. If I have the square root of 24, again, I need the list of factors for 24. So remember, I could put it in, if I go to my graph and I'm going to type in 24 divided by x, hit enter. And then do Control T, and that will give me my list, okay? So I don't have to think about it, I can get it from my calculator. Let's go ahead and just write all of them. 3 will go 8 times, 4 will go 6 times, and I believe that's all. So again, let's find all of our perfect squares. 1's a perfect square, 4 is a perfect square, and I think that's all we have. So again, I'm going to rewrite this using those factors, so 4 times 6. Again, the first one is my perfect square. Well, the square root of 4 is 2. And then 6 will remain underneath my radical sign. Okay, 40. All of its factors, 1 times 40, 2 times 20, 4 times 10, 5 times 8, 6 won't go, 7 won't go, 8 will go, but we've already used it, so we're done. So again, 1's a perfect square, 4's a perfect square, and I don't see any of the perfect squares. So we will say 4 times 10, and the square root of 4 is 2. And the 10 remains under my radical sign, and there's my answer. Okay, this next section is talking about all the exponent rules. And so the first one is the product rule. So when my bases are the same and I'm multiplying, remember that you add the exponents. So if I look at my examples, I have h to the second times h to the sixth. So my bases are both h, and it is a multiplication problem. So I'm going to add my exponents. So 2 plus 6 will give me h to the 8th power. Down here I have a few more different bases, so I'm going to rearrange them and put my like bases together. So I have my coefficients, I have my a's, and then I have my b's. Okay, so my coefficients, I am just multiplying because they're not exponents, they're coefficients. So a negative 2 times 7 is going to give me a negative 14. A to the second times a to the third, remember I'm adding those exponents, so 2 plus 3 will give me 5. And then b times b, these both have understood one exponent, so 1 plus 1 will give me 2. So here's my final answer for the second example. Here's my first. Okay, let's keep going then. The next one is the power rule. I have an exponent raised to an exponent. So remember, if I have an exponent on the outside of a parentheses, I need to distribute. But if I try to distribute and there's already an exponent there, that means I need to multiply the two exponents together. So in my first example, I've got x to the second raised to the third. So I'm going to distribute that 3. That means I'm going to end up having x to the 2 times 3, which will give me x to the 6th power. In the second one, I have a couple of things. I need to distribute this 2 on the outside, and then I'm going to take care of the multiplying times n to the third. So if I distribute, remember I'm going to go to each base, so I'm going to have negative 2 raised to the second power, and then I will have m to the 5th raised to the second power, and then my times m to the third. Okay, so negative 2 raised to the second power, that would be negative 2 times negative 2, which will give me a positive 4. M to the 5th raised to the second. Okay, if I have, I try to distribute the 2 here, but I already have an exponent, so I'm going to multiply them. So 5 times 2 will give me 10. And then I still need to multiply with the m to the 3rd power. So now, right here, my bases are the same, so I'm adding my exponents. So my final answer here is going to be 4m to the 13th power. Okay, the next one is a quotient rule. So bases are the same, but it's dividing. That means I'm going to subtract my exponents. So if I look at number 1, again, I'm going to kind of split it up. I've got 27 divided by 42, and then I have x to the 5th divided by x. I broke it up based on my bases. So I've got, again, coefficients here. So if I do 27 divided by 42, the best I can do is simplify it by 3. So 3 goes into 27, 9. 3 goes into 42, 14 times. And then if I look at my x's, remember again, if this doesn't have an exponent, it's an understood 1. So now I can say 5 minus 1, which will give me x to the 4th. Okay, down here, I've got y to the second raised to the second over y to the 4th. So I need to distribute first right here. So again, I've got an exponent raised to an exponent, so that's going to multiply. So what's 2 times 2? Well, that will give me 4, and then I have over y to the 4th. So then it's a division now, so what's 4 minus 4? Well, that will give me 0. And we haven't reviewed that. It's right down here. So I'm going to leave this one here, but I'm not done. I'll come back to it in just a second, okay? All right, let's keep going. If I do the next one, it's a negative exponent rule. I cannot leave my answer with a negative exponent. So to eliminate my negative exponent, I write its reciprocal. So if I have negative 5x raised to the negative 2, first of all, the x is the only thing that's being raised to the negative 2, not the negative 5. If it were the whole thing, you guys, it would look like this with parentheses, right? And it doesn't. So it's just the x that's being raised to that negative 2, okay? So let me get rid of that. Okay, so that means my negative 5 can stay right where it is. It's not an exponent, so a negative coefficient is fine. But the x to the negative 2 is going to come below and change to a positive 2. So there's my answer for the first one. The second one, again, I've got, I'm going to break it up a little bit. I've got 4 over 8, which I can simplify, and then I have k to the second over k to the 5th. So 4 divided by 8 would give me 1/2. And then if I have k to the second over k to the 5th, I'm going to have a k, and then 2 minus 5 is negative 3. So of course, because this is negative, it needs to come to the denominator. I need to write its reciprocal, so it's going to come to the bottom, right? So the 1 stays up at the top. I have 2 in the denominator, and now I have k to the 3rd in the denominator. And here's my final answer for that one. All right, so let's look at the next one. X to the 0 power. Remember, anything raised to 0 power is 1. You see that green? Let me try orange. Anything raised to 0 power is 1. So I have 7x to the 0 power. Again, just like this one, it's not saying 7x raised to the 0 power. It is saying 7 and then x is raised to the 0 power. Okay, so it's not this one. So my 7 is going to stay, and then what's x to the 0 power? Well, that's 1. So what's 7 times 1? It's just 7. So now that I know that, let's go back up to here. So anything raised to 0 power is going to be what? 1. So this answer right here is going to end up being 1. Okay, so I've got right here, again, I need to distribute that 2. I already have an exponent there, so that means I have to multiply. So 4 times 2 is 8. And then I have w over 8. Okay, so again, 8 minus 8 is going to give me 0. Anything raised to 0 power is 1. Okay, the next 3, we are wanting to identify the slope and the y-intercept. If my equation is in slope-intercept form, which means the y is by itself, it's pretty easy to do. So that means I need to rearrange all of this. Remember, I'm wanting my y by itself, so I will eliminate my x term. By doing the opposite, this is positive, so I will subtract to get rid of it. So that leaves me 2y. On the right-hand side, not like terms, so I have a negative 3x and a positive 12. And now I will divide everything by 2. So that will leave me y equals negative 3 over 2x plus 12 divided by 2 is 6. So remember, my m, my slope, is right here, so it's negative 3/2. My y-intercept is the b, and it is a 6. Okay, let's try the next one. I just need my y by itself, so I just have to divide everything by negative 2. Gets rid of that. So that leaves me a negative 3/2 x, and then a negative 12 divided by a negative 2 is going to be a positive 6. So again, I'm going to have a negative 3/2 for my slope and a positive 6 for my y-intercept. Okay, the next one. This time my x is here, so I just need to move my 10 over. So let's get rid of that 10 first by adding 10. So I have a negative 4y equals a negative 5x plus 10. And then divide everything by negative 4. So y equals, a negative divided by a negative is a positive. So we have a positive 5 over 4x, and then 10 divided by a negative 4 will simplify to a negative 5/2. So my slope will be 5 over 4, and my y-intercept will be the negative 5/2. If you wrote this as a decimal, it would be a negative 2.5. Either one would be perfectly fine.